So what happens if you do direct substitution like in the last section and you end up with 0 over 0? So there's a good chance that what's happening is that there's a removable discontinuity. So the function's undefined there, but that doesn't mean that the limit doesn't exist. Like in this case, the function doesn't exist, so if we were to try to evaluate it, it would probably tell us undefined, some sort of 0 over 0. But still, you can see the graph does approach this point from both sides. So in this case, what we're going to do is we're going to try to reformat the algebra, cancel some things, and see if we can get rid of what's causing that 0 in the denominator so that we're able to find out what the function's approaching. It's not what the function equals, but it's what it will be approaching. And I'll show you on Desmos right now. So let's look at this first one. So if you were to plug in a -3, of course you should try -3 first, plug it in. On the bottom though, you would see you get 9 minus 9, which is 0. So that's the problem there. So let's go ahead and try factoring the top and the bottom. And let's see what we get. So on the top, I could factor out an x. And have x squared plus x minus 6. On the bottom, I can also factor out an x to have x plus 3. And you can see this x plus 3 is what's ruining it. If we plug a -3 in right here, that's what causes the chaos and gives us the 0 on the bottom. So if we factor, we might be able to cancel it out. So right here, what is this factor to? Well, we're going to go ahead and do that diamond method. What multiplies a -6 and adds to 1 would be 3 and -2. So those factors, well, we have the x on the outside, then x plus 3, x minus 2, over x times x plus 3. And now we can see the x's cancel, the x plus 3's cancel, and we're left with the limit as x approaches -3 of x minus 2. Then we plug in the -3 and we get -5. So remember, this means that the limit, it's approaching -5. The original function at -3 doesn't equal -5, but it's approaching -5. Let's take a look at Desmos, see what we get. So I'm going to put x cubed plus x squared minus 6x, and then divide that by x squared plus 3x. So check this out. Let me make sure I'm in projector mode so it's a little bit easier to see. So as I trace it, let's approach -3. So as I approach -3, look at the x values. Right there. Right at -3, it's undefined. The graph has a removable discontinuity there. It doesn't exist. Because remember when we plugged it in, when we plugged the -3 in, we got that 0 in the denominator. However, what is the value approaching? It's approaching -5. You can see that in the y value is getting really, really close to -5. And check this out. If I graph x minus 2, it's going to give you the same graph, just like that. Let me turn off this other graph. Except this time, when I approach -3, it actually tells us the value. So keep in mind, this x minus 2 is not exactly equivalent to the original function. It is for every single value except when x is -3, because there's a hole in the graph of this. This one just helps us figure out what would that hole in the graph, what would it actually equal, which would be the -5 here. All right, just to run through one more example, and we'll go through this one quickly. So on the top, we'll have the limit as x approaches -5. On the top, we can factor out a 10x, have x plus 5. Over on the bottom would be x plus 5, x minus 5. Remember, this is the difference of two squares. If you FOIL this out, you get x squared minus 5x plus 5x minus 25. You'll see that those cancel out. Or you can also think what multiplies a -25 and adds to 0. Since there's no x value in there, there's no b, right? We can say b is 0. And that would be 5 and -5. So just kind of remember that. You should have gone over that in the past. Anyways, canceling out. And so from there, we'll just have 10 times negative 5 over negative 5 minus 5, which is negative 50 over negative 10. Let me give myself a little bit more space. And that equals 5. So there's a couple more examples over here, but we're going to work on those in class. It's pretty straightforward. It's just factoring, canceling in, then plugging it in. So most of the time when you end up with 0 over 0, this is something we can do.